today is to remember everything we did in Unit 4. Okay, we're getting ready for our test. So we started out Unit 4 by being able to look at two similar figures that maybe had been rotated or reflected, moved around, and figure out all of the congruent parts. Now, let me narrow my focus on this quadrilateral in number 1, okay? Before I start trying to name anything, I need to figure out some of these missing angles. A quadrilateral has 360 degrees. What's this little mark mean, this little square? That's 90, and so this is 90, so A is 113. I need to figure out what F is, because if these two figures are similar, all of their angles have to be exactly the same, and I can't assume that they are. So there's 360 degrees in a quadrilateral, minus both of the 90-degree angles, and minus the 113 for A, leaves you with 67 degrees for F. Now, what did that just prove? What's F congruent to? D in the other. Now, let me check that one. 360 degrees minus the two 90-degree angles minus the 67 truly does leave 113. So, what did that prove? Angle B is congruent to which angle? To angle A. Alright. So now, your statement is FCAH. What is F, which is 67, congruent to? D. Now, C might get a little tricky, okay? Here's how I figure out what matches C. When I leave 113, to get to C, I'm going to slide down to 4. 4 is the smallest side in the whole figure. So if I leave B, what's the smallest side in the figure? 2, so I'm going to leave me to G. Okay. And then A is 113. What angle is congruent at 113? B. And then H goes from 113 down the next to the smallest. So 113 to the next to the smallest, or the other letter we haven't used, is E. That just helped you figure out what are your congruent angles. Meaning, not just that are they the same, that they're in the same corresponding part. So, if you had to list them separately, so you listed me, that says a congruent statement, that should say a, well, I guess those are congruent. Similarity statement right here, that's what that should say. Now, if I'm going to list the congruent angles, I have angle F, I have angle C, I have angle A, and I have angle H. What did we just decide that angle F is congruent to? F is 67 and so is D. Angle C we decided was congruent to angle G. Angle A is congruent to angle B. And that leaves angle H congruent to angle E. Alright, so let's write the proportion that relates the corresponding sides. If you've got a similarity statement, you've got 4 sides, you're going to have 4 fractions. To me, it's pretty easy to organize myself. I'm going to go F to C, and I'm going to go C to A, and then A to H, and then H back around to F. I do that so I don't leave any statements out, any sides out. If I've already written the statement, F is congruent to what? D, and C is congruent to G. C is congruent to G, A is congruent to B. A is congruent to B, and H is congruent to E. H is congruent to E, and F is congruent to D. So that is a proportion that relates all of the corresponding sides. Alright, so the last part of this question says that I need you to determine the scale factor for each set of polygons, show your work for all the sides, and start from the first figure listed in the congruency statement. So, Since the congruency statement starts here, I'm going to start here and I'm going to move to that one. That means the side links from here go on top. The side links from here are going to go on the bottom. So this is just a way of reminding myself, start here, go to there. So I'm going to need my 4 fractions. You've already got them set up. What is the length of, you could go with the length of FC. What is the length of FC? 6. What is the length of CA? 4. What is the length of AH? 5. And the length of HF? 7. I just went with the proportion I'd already set up. You absolutely could have looked at these and said, I'm going to set them up in order, 4, 5, 6, 7. And then you would just go here and you would set them up in the numerical order 2, 2.5, 3, 3.5. All right, look at another figure. D to G is what length? 3. G to B is 2. B to E is 2.5. And then E to D is 3.5. In order for these to truly be similar and have a scale factor, they have to all reduce to the exact same number. So I'm going to check those numbers here. So I'm going to do 6 divided by 3 and I get 2. I'm going to do 4 over 2 and I get 2. So far, those two are equal. 5 over 2.5 gives me 2. 7 over 3.5 also gives me 2. They all reduce to a scale factor of what? 2. It could be a fraction. That's fine. So you're going to reduce and make sure it reduces to the exact same thing. All right, so let's look at number 2. I'm going to have to figure out the similarity statement. I need to figure out what angle is congruent to E, to D, and to P. So look at your numbers. I've got 82 and 60. I have 60, so I know that E is congruent to A. I don't know this third angle. This is a triangle, so how many degrees are on the inside of a triangle? 180. I'm going to take away the 82 for M. I'm going to take away the 60 for A. And I find out that this angle is 38 degrees. I need to find this one. 180 minus the 38 minus the 60 gives us 82. What do you notice now that I filled in all those other numbers? Everything's got to match. What angle is congruent to angle E? What other one is 60? A. D is 38. What angle is that in this triangle? G. And P is 82, which matches with M. So when you write a congruency or a similarity statement, and then you're telling me the congruent angles, you really are doing the same thing. You see, if I have E, it's congruent to angle A. And then you just told me that angle D is congruent to angle G. And then you just told me that angle P is congruent to angle M. Writing them out is the same exact information you need to figure out as writing them in that similarity statement. Because wherever they line up, those two are equal. Whatever lines up second, those two are equal. And whatever lines up third, those are equal. So order does matter. If you're looking at an answer choice on a multiple choice test and the letters are flipped, that's not the same answer. Okay? All right, so now you're going to set up a proportion statement. So I've got 3 sides, I'm going to have 3 fractions. I find the easiest way to do this is if they named this triangle, I did ED, D to P, and P to E. So E to D is the same as A to G because E equals A and D equals G. D equals G and P equals M. P is M and E is A. So you could set up to find your scale factor either using this proportion or you could do a small, medium, large situation. Okay? okay? I've got 3 sides, so I'm going to have 3 fractions. I'm going to set it up, because we set this proportion up, I'm going to set it up by that. E to D is 16. A to G is 24. D to P is 12. G to M is 18. P to E is 10. And M to A is 15. What I hope you notice is the smallest 2 numbers are set up because they are proportional. The 2 numbers that are the middle length are set up proportional. And the 2 largest sides are set up proportional. So now you have to check and see if they truly have a scale factor. A scale factor is going to reduce to be the same thing. So I get 2/3. 12 over 18 is also 2/3, so those are equal. And 10 over 15 is also 2/3, so what is my scale factor? 2/3. That means this is 2/3 as big as that. Now, I should have pointed out, it said for me to start with the one they mentioned first. That's why I started here and went to this one. So it matters. If I told you to start with left to right, your scale factor would be flipped upside down. So you absolutely have to start with the one that you're told to start with when you're finding scale factor. All right, so then you could have some questions like this that simply say, what is the scale factor given that RGWD is similar to quadrilateral XKVM? That means you start at the first one you listed. RGWD happens to be this side. And you're going to go to this figure. What that means is the first one listed goes on the top. Now look at the 2 sides you know. Which of those 2 is smaller from this quadrilateral? The 36. So I'm going to list that first. Only because that helps me get organized. Now, you started at this quadrilateral, you're going to move to this one. You have to line up the small side with the small side. What is the smallest side of 30 and 35? 30. And then the biggest would be 35. So now, if these are in fact proportional, they will simplify to be the same number, and that number is called your scale factor. So 36 over 30 gives you 6 over 5. 42 over 35 gives you 6 over 5. So they are proportional with a scale factor of 6 over 5. All right, look at number 4. Given that HZM, which is this one, you have to start there, is similar to that one. So that means the one they told me to start with has to be on top. Now, I have 3 sides here. I only have 2 here. So I want to set up my proportion. Tell me my small, my middle, and my large side right here for this one. That would be 20, 24, and 32. Now, you know that H is congruent to Y. And you know that Z, where's that, is congruent to J, and then S and M, okay? You've got to figure out which side matches. I'm missing a side. What is 18 from S to Y congruent and proportional to? H and M. So that would be 24. So I got to line 18 up in the right spot. 24 SJ. What is that in the same spot so it's proportional to? Z and M, which is 32. So 24 goes with 32. Thank you, friend. I lost my place. I don't know this one, so guess what? Don't worry about it. You got to set up and find your proportion. So 32 over this 24. Little 24 over little 18. So let's simplify. 24 over 18 is 4 over 3. 32 over 24 is 4 over 3. So what's my scale factor? 4 over 3. So the important part when I'm trying to get you to tell me scale factor, whatever I tell you first, those measurements go on the top. Whatever it's similar to second, those measurements go on the bottom. If you get it lined up wrong, then you're going to be wrong. So the first thing I mentioned is the top. The second part of the similarity statement is the bottom. Alright, so for the next several questions, it says, are the triangles similar by angle-angle similarity, side-side-side similarity, side-angle-side similarity, or just not similar at all? If they are similar, then you're going to complete the similarity statement. If they are not similar, you can't complete a similarity statement. Alright, so let's focus on number 7. Does number 7 give me any side lengths at all? Nope, so it can't be side-side-side or side-angle-side. Now, you have to make sure that you have 2 sets of congruent angles. This angle is marked with 3. Is there any angle over here that's marked with 3? Yep, so L and C are congruent. This angle is marked by 2 lines. Is there any angle in the other triangle marked by 2? Yes, they have to be marked exactly the same. So since you have 2 sets of congruent angles, this is angle-angle similarity. So that's one answer. Since they are similar, now I need you to complete this statement. If you start with triangle BCD, that is similar to. B is marked with 2 angles, so what's that similar to? K. C is marked with 3 arcs, so what's that similar to? L. And then D is not marked at all, so that must be similar to N. So you're looking for congruent angles and proportional sides. If you ever have sides, you got to do some math. Alright, so the next one. I do notice that they give me 2 sides. If all I have is 2 sets of sides, could it be side, side, side? Nope, can't be side, side, side. Do they give me 2 angles? No. Is there any way for me to figure out a second angle? No, so it's not angle, angle. As soon as I look at this, I've got an angle between 2 sides. I'm suspicious that it might be side, angle, side. Now let me make sure this is set up side, angle, side. It's set up in the right way, but that does not guarantee they're similar. I have to check my proportion. Alright, so look at this top triangle. Alright, actually they mentioned the bottom one first, so let me go with the bottom. Look at the bottom triangle. What's the smaller of the 2 sides down here? 14. So I'm going to do small, large. I started with the bottom because that's what the similarity statement mentioned, and that's how you have to do scale factors, so I want to try to be consistent. Alright, look at the top triangle. What's the smallest side? 7, so small with small, and then large with large. Okay? Alright, so now I gotta grab my calculator. Really, I could probably do that in my head. I should be able to, but not always. 14 over 7 simplifies to be 2. 18 over 9 simplifies to be 2. They simplified to both be 2, so what does that mean about them? They are proportional. So, what you have here is 1 set of proportional sides. You've got another set of proportional sides. Slusher, you marked the wrong side. Sorry, friends. 9 is proportional to 18. And you have an angle in the middle. So what similarity theorem will prove these are similar? Side, angle, side, similarity. And since they are similar, you can complete this statement. Alright. Angle J is congruent to which angle? Angle J and D, because they're marked the same. Now, K is at the end of that short side. So what's at the end of this short side? C. And then it follows on around to B. If you don't get these in the exact right order, you're wrong. You have to make sure they match up. And in order to do that, you're going to have to look at the numbers and see that from J, you slide down the short side, so you got to slide the short side. And then L is at the end of the long side, so B is at the end of the long side. All right, so let's go on to 9. Looking at number 9 here, they didn't give me all 3 sides, so it can't be side, 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 so no big deal. Is there any information that you know for certain that you might need to use? What do you know about the way that these crisscross? That creates a set of vertical angles. So it creates this set of vertical angles right here. And I've got an angle in between 2 sides. So possibly side angle side, side angle side. Before I can just say, yep, it's side angle side, what do I have to check? I've got to check that proportion. Now, my similarity statement is going to start me with DCB, so I'm going to start with this side. What is the smallest of this triangle? Smallest side. 55, and then the largest, 64. Match up the proportional side. What is the smallest side of GFD? 7, so small with small, and then large with large. Now, let me find my calculator. I'm going to type that in. 55 over 7 simplifies to be 55 over 7, so it didn't change. 64 over 8 simplifies to be 8. Are those two resulting in the same thing? No, so they're not equal. If they are not equal, are these proportional? No. If they're not proportional, then they are not similar. If you know anything about your sides, you have to definitely know that they are proportional. All right, let's go to the back. We're still doing the same thing. We're trying to figure out, are they similar? What's the theorem? And then complete the similarity statement. All right, now, this looks like the last one we have. We have 2 lines that crisscross, and when these 2 crisscross, what do they create? They create a set of congruent vertical angles. And so now I'm set up to have a possible side angle side. So I've got to do my proportion. This statement starts me at my right triangle, so that's where I'm going to start. So PQR, what is the smallest side in triangle PQR? And then the big one is 54. Now look at the other triangle. You want to get the proportional, small with the small. What's the smallest side over here? 5 and 9. So let me get my calculator back out. I'm going to simplify those. I get 6. 54 over 9 gives me 6. So these really are proportional. So what you just proved to me is the small side is proportional to this small side. And the large side is directly proportional to the large side. So what situation did we just mark there? What theorem? You got a side, an angle, a side. A side, an angle, side. So this truly is side, angle, side similarity. So when you try to write your similarity statement, P in this triangle is congruent to what letter in the other triangle? P, because it's a vertical angle. All right. Q is at the end of the short side. What's at the end of the short side here? K. R is at the end of the long side, so the end of the long side in the other triangle is L. All right. Number 11 can get a little tricky. It can get a little tricky because you have a triangle inside of a triangle. All right, so let's look at what they give me. My big triangle has all 3 sides. My little triangle has 2 sides. Can you find me what's left for EL? How would you find EL? If the whole thing is 99 and this is 81, what would you do? You're going to subtract it. So 99, well, if you hit the right button, 99 minus 81 they already used, there's 18 left. You know 3 sides of the small and 3 sides of the big, so you could set up your proportion to try to prove side, side, side. Okay, so it starts me with the big triangle, LMN. I need to know the length of this side. If it's 20 from here to here and 90 from here to here, what's the whole thing? 110, thank you. So you've got 99, 110, 154. That's your small, your medium, your large. All right? In your smaller triangle, you've got small, medium, large. 18, 20, 28. In order for this to be similar, these proportions have to be the same. So you've got to check all 3. 99 over 18 gives you 11 over 2. 110 over 20 gives you 11 over 2. So these are good. Now, if the third one's not similar, or not the same, that means the whole thing's not similar. 154 over 28 is also 11 over 2. So what did you just prove? Which theorem? You proved side, side, side. Is there another similarity theorem that would work? Which one? Side, angle, side. What would make side, angle, side work? The L. They both share the L. So, both of those similarities are fine. I would take either one. So now you need to complete the similarity statement. LMN in the big triangle, that's going to start out with L, go towards M, and that leaves you at D, go towards N, that leaves you at E in the small triangle. Alright, so this one kind of gives people some trouble. Alright, what do these little 2 triangles mean? That means that those lines are parallel. If these lines are parallel, that means BA is a transversal, and B meets the parallel line in the same place that V meets the parallel line. What allows these B and V to truly be congruent? What kind of angles are those? Those are your corresponding angles. Now, tell me another angle that's congruent here. You could tell me A is congruent to itself, so that would prove by angle, angle. Also, C is congruent to W. So this would be angle, angle, similarity also. And so then A, B, C would be congruent to A, V, W.